Okay, so let's calculate it. I guess if I have to calculate the range for a quadratic equation, this we have read it in previous weeks, right? In week 3, we have read about this, the quadratic equation. Okay, so let's, for example, this we are considering this as a gx. So for this gx function plus 20x minus 36. So this is sort of a parabola, right? So this parabola, okay, if I have to calculate, this can be a parabola. You can just think of as a parabola going downward, right? So what you're supposed to calculate, can you just calculate the center of this parabola, or maybe let's calculate all the values for which the functions. Okay, yeah. Can you calculate the range for this function?
Sir, it's going, so the range is up to 64 from minus infinity. It will have the maximum value.
Okay, so it will be something like minus infinite to 64. Correct. So this will be something like this, right? So the maximum will, at which point the maximum will be attained, that you can differentiate it, right? D of gx by dx equals to 0, right? So minus of 2x plus 10 equals to 0. So x equals to 5. So at 5, right? At x equals to 5, the maximum you will be attaining. And what will be the maxima? G of 5. G of 5 is 64. That is what you have said. Correct. So yeah, so this value is 64. So the value, the function.
I think
Okay.
you made a mistake. While differentiating, it's 20. You have written 10.
Yes, sir.
Okay.
That should be 20.
Okay. Sorry. Okay. So minus of 2x plus 20 equals to 0. So x equals to 10. So here x will be equals to 10, at which the maxima will be attained. So this will be x equals to 10. Okay. And then if you'll put x equals to 10 here, you'll get 64. Correct? This is correct, right?
Yes, sir.
Okay. So this maxima will be, and then you can see that the value that this function can have, the range for this function, the range of gx will be from minus infinite, because you can see that it can attain minus infinite, right? At some minus infinite value, it can attain minus infinite, right? It can go maximum till 64, because you can see that here the coefficient of x square is negative, so it will be a parabola going downward, right? So the maximum it can get it is 64. So this would be the range for this gx. Now if I'll apply the logarithm function on that, so what will happen if I'll apply, you can the function values from minus infinite to 64, right? So log of minus infinite, what will you get? Will you get anything?
Sir, it will be defined from 0 to 64.
Correct. So
The
it will be defined from 0 to 64, because that doesn't come in the domain itself, right?
Yes,
So
sir.
this will be something you'll be writing it 0 to 64. Correct? 0 doesn't get included. Now, so at which point the logarithm you'll be getting a 0, you can get it 0. So log of what you can get it as 0.
This part I didn't got. 0
Sir,
to
base is greater than 1, so it will be minus infinite.
Correct. So it will be minus infinite. Minus infinite. And then what about log of 64 base 2?
2 to the power 6 means it will be 6.
Correct. So
this
this would be
0 to
answer.
64.
Yeah.
Minus infinity to 64, that I got, but 0 to 64.
Okay. Because minus 60, minus infinite to 0 can't be in the domain, right? You can't put log of minus 5, right? Base 2. This is not possible, right? So because this is not possible, so what are possible? So wherever the function, this value gx would be greater than 0, right? Those
Minus
can be in,
64 to minus infinity is in the range now, so we can put.
but you can't put it here, right? In gx. This is the range for gx, right?
Hmm.
gx is this function, the quadratic function that is inside logarithm function. Okay, so minus infinite to 64, but this minus 65 minus infinite to 0 can't be the domain for this logarithm function, so that you can't put. So you can put, so the range that it can take, the range of this gx that can become the domain for this logarithm function is what? From 0 to infinite only, 0 to 64 only, right? Is this making sense or not?
Mm, not getting.
Okay, what I'm trying to say is, so you got so for this function, logarithm of gx base 2, correct?
Mhm.
And the range for this function is minus infinite to 64,
Yeah.
correct?
Right.
Yeah. Now for this function fx,
Mm.
for this function fx, what are the domains? Domain is such a way that gx should be greater than equals to 0, right? Gx should be greater than 0, right?
Gx should be
2 to 18, sir.
2 to 18. Yeah, correct. 2 and 18.
Okay, that is fine. No, that I can understand what you are trying to say. You are just putting this as a greater than 0. Okay. Now what I am trying to say is, so this gx, what are the values that you can get for gx? Gx can
0
give
to
you an
64.
minus infinite to 64, right? Gx you can get it.
Sir,
Correct?
how we are getting minus infinite? When we put 2 as a point, we get 0 answer for gx.
Yeah, that you're telling, like, since Gx is here coming negative, so you're trying to make it positive from 64 to.
No, no. The thing is that gx is not getting negative somehow for me. From when I put 2 now, I'm getting answer 0.
Okay, and both methods are correct. Whatever you are trying to do is, what you are trying to do is, so whatever gx that you have, minus x square plus 20 x minus 36, you are just putting directly is greater than 0, right? From here you are getting x as from 2 to 18, correct?
Yeah.
That is what you are getting, right? That this method is also correct. But what I am trying to do is, and many of you have done that, you have plotted the parabola and then you have tried to calculate the range for this function itself, the
Hmm.
range for this function. And if you'll calculate the range, you can see that at x equals to 10, you are getting 64, right? So that is the maximum value that the parabola, this parabola can have. So minimum value it can have minus infinite, right? So this parabola might go something like that, right? Where at minus infinite it can have a minus infinite value, right?
Hmm.
Yeah. So that is what. So for this, the range is from minus infinite to 64. But minus 65, minus infinite to 0 is not useful because we can't put it here, right? Because that is under log.
Yes, minus. You can.
You got it, right? So you can, what you can get it, what you can put here, right? 0 to 64.
Zero. Okay. Okay.
Yeah, and from this 0 to 64, what are the ranges, the fx value that you can get? So because this log is a monotonic function, so you can directly calculate at 0 and then at 64, and whatever value that you are getting corresponding to x can be the range for the logarithm function. Is this clear to everyone?
Yes, sir. Sir, this 0 to 64 is the possible values that we can put inside this argument, right?
Function, correct, for fx, correct.
Okay, so just because it is an increasing, I mean strictly increasing function, so
Yes,
at like at the minimum value, it will have the minimum, and at the maximum
correct.
value, okay. That's
Yeah,
why,
yeah,
I mean, that is the process we can find the range, right?
yeah. If
Okay.
the function is, yeah, logarithm, because
Just including the negative, as negative is not allowed in the log.
negative can't be allowed, no, in the
It can be
logarithm.
taken in the GX. GX
In
can.
can gx can't take negative value, but it can
Or
come under
log.
fx because fx can have any value, right? Logarithm
Yeah.
can give you anything, right? The range for any logarithm is r, right? That
Uh,
goes
but
from,
but GX argument itself should not be negative. That's what.
correct. That can't be negative.
Okay.
Okay. If this is clear, can we move to the next question? Anybody has any doubt in this?
But here no option is 0 to 64.
No, we are asking range for this function fx, right? So that will be from minus infinite to 6, right? Okay, so to avoid the confusion, this fx, we got it as gx, right? And what was the range for this gx? That was from 0 to
From-
64. Like we can write it as minus infinite to 64 also, but minus infinite to 0 is not useful. So now we put log of 0, right? You'll be getting at minus at like around 0, right? So at which point you'll be getting at which, sorry, not log of 0. So at which point you'll be getting 0 as an answer for logarithm function? At minus infinite, correct?
Hmm.
So fx can have minus infinite, right? Until if you'll increase the value of like if you'll increase the value of gx, right? What are the values that you can get it attained for fx? You can attain what? 64 if you'll put, you'll be getting 6, right?
Okay.
Yeah, so that's what will be the range for this function.
Okay.
Okay, can we move to the next question? If this is clear to everyone. Is this clear to everyone?
Yes.
Yes, sir. Sir, it is one-to-one function, right?
Yeah, this is one to
This
one.
entire f of x.
That will be 1 to 1. Yeah.
Okay.
Okay, the next problem is regarding that only. So you have been given something like, again here is fx. Put in this color so that to avoid the confusion. Fx equals to log of gx, okay, base 10. Gx again is here, gx again is a quadratic function here. Then you have to tell which of the following are true. Logarithm function, if you have anywhere like that, will be a 1 to 1 function itself. So first one is correct, only you have to check the interval, okay. Okay, this quadratic gx, if you'll plot, what will I get? Parabola going upward, right?
Yes, sir.
Okay, and what point, what we are supposed to calculate? We are supposed to calculate on the interval 0.5 to infinite, is this increasing or not? Sorry, strictly increasing function, and then 1 1 or not. Okay, so for gx, if we are able to calculate regarding the gx, what is the at which point the can you tell me the for this function gx, right? So logarithm function, so for this function quadratic, for this quadratic equation, tell me from which point to which point the function is decreasing and increasing. You have to calculate the vertex,
Sir,
right?
1/2.
Yeah,
Vertex half and 3/4.
vertex at x equals to 0.5, right? So from minus infinite till 0.5 it is decreasing, and then from 0.5 till infinite, right, it is increasing, correct?
Yes, sir.
Okay, right. So now tell me the first option is correct or not?
No, 1 2
Yes,
1.
sir, it is
Yes,
correct.
yes, yes, it's correct.
The
It's
first one
taking
is correct.
one part of it.
What about the second?
No, no.
Second, I guess is also correct
Second will
because the
also.
base is 10.
Acha, strictly increasing. So yeah, yeah. It is.
What about
Plus,
the third one?
Third is incorrect, sir. This
oh
is
no,
the opposite of
minus infinity to yes, half
0.5.
of
Yeah.
the decreasing.
Yeah, the third one is incorrect.
Mm.
Okay, how many of you have understood this and able to solve this?
Yeah, got it.
You got it, right? See, logarithm function, as I was saying, right? You can see that it's a 1 1 function, that is totally fine, because see, this function is increasing from 0.5 till infinite, right? So for sure the logarithm function will be increasing, okay? Because logarithm of whatever value that you're getting 0.5, whatever value you are getting c1, and any value that you take log of 1, okay, whatever C2 if you'll be getting, C2 will always be greater than C1. Okay, similarly you can take log of infinite also. If you'll get C3, this C3 will always be greater than C2 will be greater than C1. Is it fine? Okay, this is fine, right?
Yes, sir, it is fine.
Yes.
Let's go to the third one. Yeah. So the third one is here it has been given that. Okay, so it has been given that in a city, a rumor is spreading around the safety of the corona vaccination. If okay, so there's one function that has been given to you, ft of n e to the power minus kt, and it has been said that ft is the number of people who are not yet heard about the rumor after t days. So after this function just tells you, this function tells you the number of people who are not aware of anything about the corona, okay, till after tth day. Okay, and k is some constant and n is the total number of population. This n represents the total number of population, and if the total number of population is 10k, right, 10,000, and suppose that 100 people have heard the rumor after first day, have heard the rumor after first day, then after how many days would the half of the population would have heard the rumor? So in a city, the rumor is spreading around the safety of a corona vaccination. If ft is the number of people who have not heard, ft denotes not heard people. Okay, I got it. Yeah. So what you're supposed to do?
Put ft is equals to 5,000 and get the value of kt.
Sir, n is 10,000 here and
100 they have heard, so we can
yeah,
subtract 1000 minus 100, that is 9,900, that would be ft is equal to
sir, yes. First,
n.
we have to find the value of k, right?
N is the total population, so it 10,000, 9,900 is equal to 10,000, and then e to the power k is a constant, and t we have to find.
Yeah, one. I guess I in the previous
Half of
question.
the population.
Okay. I guess in this question somebody was asking about this is increasing or decreasing, right?
Yes, sir. Actually, it is, sir.
Yeah.
It is not one to one, right?
Yeah. This depends on this function f gx. Okay.
Yes, sir.
Yeah. Okay. Even I thought okay. I something else I thought okay. So it all depends on the gx. However, the gx will respond, right? Because this is totally monotonic, right? So however gx will. So in the second question you can see that,
I
right?
think there is issue with your mic.
With my mic. Is it
Can't hear
fine?
you.
Can't hear. Is it with everyone? Nobody can hear. Like, is the voice not clear?
It is clear, sir, now.
Okay. So what I was trying to say is, so this log is a very monotonic function, right? So it will totally depend upon whatever the function that is inside, right? The logarithm. Okay. So if gx was, let's for example, it was increasing or decreasing, it was increasing till this value, right, x equals to 10. So the log will also keep on increasing till x equals to 10. Okay, and if it is decreasing from x equals to 10 to infinite, so the logarithm of this function will also decrease. Okay, so depending upon whether it's a 1 1 or not, if we have been given some sort of a domain, let's for example from minus infinite to 10, right, then the function is 1 to 1, you can say that, because this part only will be plotted. Okay, and from x equals to 10 to infinite, right, the way this quadratic will behave, the same way the logarithm also will behave. Okay, let's go to the this question. Is my voice clear or not? If it's not clear, I'll join it from some other device.
It is clear now, sir.
Okay. Okay, so how will you solve this problem? I hope the doubt is clear, right? So the log that I said by mistake is always 1 1, right? That's not correct. It all depends on the function, right? The function inside the logarithm function. Okay. I just told about this logarithm function. Okay, but if the log has a different gx, right, the composite function, then it'll change. Yeah, how will you solve this problem? So fx has been given to you, ft is equals to n e to the power minus kt, correct? Now it has been said that the 100 people have heard the rumor after the first day. So what should I write here? So this is the number of people who have not heard, right? Then what is the number of people who would have heard? This would be n minus ft, correct? N minus ft equals to 100. So, and capital N is 10,000. So you'll be left with what? 10,000 minus 100. So it will be 9,900 equals to ft. So ft is 10k, 10,000 e to the power minus k times 1, right? Because after 1 day only, this is the number. And equals to how much? Equals to 9,900. So you'll be left with e to the power minus k equals to 0.99. Okay, so from here you can calculate the value of k, right?
Yes, sir. That
Okay.
would be minus ln 0.99.
Minus ln.
Yes, sir.
Okay, you can take, yeah, minus k equals to ln 0.99. So this value also will be negative, so you'll get a positive value, right? So now you have the value of k, right? What else has been asked? How many days would the half of the population would have heard the rumor, right? So what should I do now? So 10,000 e to the power minus kt. This k value you can put it from the value like the way we have calculated, right? Should be equals to how much? Half of the
5
population, 5,000.
5,000.
Okay, so this got it. So e to the power minus kt equals to 0.5, correct? So minus kt equals to ln of 0.5. K is what? K was ln of 0.9, right? So t will be equals to minus of ln 0.5 upon ln of 0.99.
Sir, minus k was
Minus, yeah.
ln 0.99. So it would
Yeah,
be
here,
plus.
correct. Yeah,
Yes.
it got plus. So you'll be having t equals to ln of 0.9 upon, sorry, 0.5 upon ln of 0.99. Is this clear to everyone? This was not difficult, just simple, right? What happened? Nobody is saying anything. Is this difficult? Not difficult, right?
Yes, sir, it is clear.
Okay.
Sir, can you explain this again?
Okay. So what I was saying is, it has been said there, the problem, see, given equation is ft equals to capital N e to the power minus kt, where ft denotes the number of people who are not aware of or have not heard of the rumor after t days. Okay. In the question, it has been given the capital N value is 10,000, right? So in this equation, you can see that there are two variable n and k. N is already been given to you, sorry, k and t, because n is already been given to you, right? So k and t. So you have to get the value of k for sure, right? K is some sort of a, not variable, some sort of a constant, okay? That you have to get. Then only you will be able to calculate anything. Because see, any equation, let's for example, if you have the equation has been given as ax square, right? Something like that. So you need a value, right, to calculate anything else. So here also in this equation, you have a one constant k, right? That you need. So to calculate the value of k, there is one thing that has been given in the question. If the population of the city is 10,000, that is like capital 10 has been capital N has been given to you as 10,000, and suppose 100 have heard the rumor after the first day. It has been said, right? But here in the question, it has been said ft denotes the number of people who has not heard. But in the question it has been given 100 people has heard after 1 day, right? So if you have been given ft as the number of people who has not heard, then if you have to get the people who has heard, then that will be n minus ft. Correct? So n minus ft will be 10k minus whatever ft equals to 100, because 100 has been given to you. Correct? So now you can equate it. So 9900 equals to e to the power minus kt. Right? Here you can see that t value has been given to you equals to 1 days, right? So now in this equation you just have one variable or a constant that you have to calculate, k. So from here you can calculate the value of k. Now you have the equation, the whole equation. Now it has been asked that after how many days would the half of the population would have heard the rumor. Okay, so what you will do is again the same thing, ft minus capital N equals to how much? 10,000, sorry 5,000, right? Correct. So now the equation will become e to the power minus kt nt times 5k, 5,000. So here you have 10,000, so you'll be left with 0.5 here, and then if you'll just solve this equation you'll get the value of t. That is what you have to calculate, the time after which half of the population would have heard of the rumor.
But T
Is
we
this
already know is 1, right?
no t, see here it was given that after 1 day, okay, 100 people got to know about that. Correct? But that t was given to just calculate the value of k, so that you will be having the equation, and then in the end you have to calculate the time after which half of the people will know about the rumor.
Okay.
You got it, right? See,
Yeah.
here the first day it has been just, you have been given an information that after first day 100 people come to know. Now tell me after how many days half of the people will come to know. Okay?
Okay.
Yeah. Let's move to the next problem. So all the solutions are attached here. So I'll just upload the slide. You can just go through it also. Again, here it is. Okay, you have to calculate the inverse of this function. I hope you know, right? Just replace x with y and then calculate the equation of in the term of y. Okay, or maybe right here it has been given, right? This y has been given in term of x, right? So what you can do is you calculate, equate it y equals to 15 e to the power x by e to the power x plus 1, right? So just put the x in the left side, okay, and then x should come in the term of y, okay. Just you want to do, you have to just calculate that. What do you have, what are you supposed to do? For this equation you have been given y equals to 15 e to the power x by e to the power x plus 1. What you're supposed to do, the simple method is replace y with x, okay, and then get the y. So if you'll replace it, what will you get? X equals to 15 e to the power y, sorry, 15 e to the power y upon e to the power y plus 1 equals to x. Now try to put the y in the right hand side, okay? You just have to get y in term of x after replacing y with x. That will be the inverse, right? Will you be able to do this? This is simple, right?
Sir, the first option,
Yeah, the first one's option is correct. Okay. So nothing, right? Y equals to, so
sir, why is it written y here? It should be x, right? So the function is in terms of y here, f inverse of x,
mhm.
but it is y there.
Okay, here you are saying.
Yes, sir, in the option only.
Instead
Okay,
of
okay.
y, there should be x.
Yeah, okay, got it, got it. Yeah, got it. Well, you know the process is clear, right, to everyone? Replace y with x. So if you have replaced, so you'll be left with x equals to 15 e to the power y by e to the power y plus 1. Now how will you put all the y in one side?
Sir, we can consider f inverse of x as y. Let's consider that. And we can find FOG of x should be equal to x. Then in that process, we can find the inverse.
Taken a simple approach rather, like y is equal to this expression, then multiplying and keeping e to the power x one side and all the y term another side, and just taking the log.
Yeah, ln we can apply then.
Yeah, that's what.
Okay, how x times e to the power y plus 1 equals to 15 e to the power y.
Yes, sir. Then
Okay,
e to the
yeah.
power y, 15 minus x is equal to x.
Okay, x e to the power y minus 15 e to the power y.
Yes, sir, that would be correct. Should be equal to, no, sir, I'm saying that 15 e to the power y minus x e to the power y equal to x.
Okay, so you are trying to say,
Sir, 15 e to the power y
okay, 15 e to the power y
is
and
equal
then,
to x into e to the power y plus x.
okay, 1 second.
Why we are taking x? It's rather than y into e to the power x plus y.
Yes, sir, that should be x.
X by 15 minus x. And then if I'll take y,
ln you can take.
yeah, x upon 15 minus. Okay, thanks. Yeah, this way you can calculate the inverse.
Sir, we also need to check the one-to-one, like first we have to check that, right?
Well, you can check it, right? See, this function is what? Ex to the power ex plus 1, right? Just check what is this function. See, this function is something like what, decreasing or increasing function. You keep on increasing or decreasing the value. Let's, for example, you have any function x upon 1 plus x. What will happen to this function? If you have 0, you will get it 0, right? And if you will put infinite, right, you will get it as 1. So this is an
Decreasing
increasing
function.
function. A decreasing, increasing function, right?
Okay, sir.
See,
X
Otherwise,
by
we
1
can,
plus x. No?
x
So
upon 1 plus x, right? So let's, for example, you are putting
sir, we can find f of x1 equal to f of x2 in that way also. Then if x1 equal to x2, then it would be considered as 1-to-1.
can this function be written as a 1 by 1 plus x divided by x? And then it can be equated as 1 by 1 by x plus 1.
can you repeat that?
Can this equation be written as you're writing x numerator and x plus 1 in the denominator? So I'm just taking the numerator x in the denominator and taking 1 in the numerator, then 1 by
X plus 1 by
1
x.
plus x.
This way.
Yes. On upper there would be 1.
No,
Numerator it would be 1. Numerator it would be 1. Just taking x like
okay, 1 upon x.
1 by x plus 1, then x. X plus
Yeah.
1,
Okay.
then by x. Yeah, this. Just taking x in the denominator. Then can we write it
Sir, are
1
we
by
checking the one-to-oneness of this function here?
Yeah, 1 1 1 we are trying to check.
Then, sir, we can just put f of x1 is equal to f of x2. If we are getting x1 is
No,
equal
no.
to x2, then it is 1-to-1. In that way, and we are getting that actually, x1 is
No,
equal to
yeah,
x2.
I got your point. See this function, right? E to the power x upon 1 plus e to the power x, right? This e to the power x can be negative. It can't be negative, right? So this e to the power x, what can be the minimum value for this e to the power x?
1.
The minimum value can be 0, right?
It is not exact. I mean,
Well, like, yeah, like approximately you can get 0
Mhm.
upon 1 plus 0, right? So minimum value
Yes,
you can get it 0, right, for this function.
yes, sir.
Okay. And what can be the maximum value when the value e to the power x will be infinite, right? E to the power infinite upon 1 plus e to the power infinite, correct?
Yes, sir.
So we'll be getting 1 approximately. Like here you are getting 0 and here you are getting 1, right? So the function value, as the x increases, the function value is increasing.
Yes, sir.
Okay, because see x, when even though you will take it as minus infinite, right? At minus infinite, what was happening? E to the power minus infinite upon 1 plus e to the power minus infinite. So the function you were getting it as 0, right? Approximately 0. And then when you put it as infinite, you were getting close to 1, right? So this function is increasing function, right?
Yes, sir.
You got it, right? So even though if you'll apply log on this, so it will be increasing. That doesn't work on this. So this was a wrong example. Why wrong example? When I got confused, because see, from x equals to 0 to infinite, this will work properly. But when the value will be negative, right? Minus infinite upon minus infinite. Again, it will also be close to 1, right? So it will not work from minus infinite to 0. So it will be again a decreasing function. But yeah, so that's why this example will not work. But this example, e to the power x upon 1 plus e to the power x, because e to the power x can't be negative, so it will work properly. Are you guys able to understand it, or
Yes, sir. It is clear.
right? And the other example, somebody was saying anything else, right? To approach this. What was that? I couldn't understand that.
Sir, okay.
Um, which one, like, which approach you're talking about?
Mm. So somebody was saying something. Okay, fine. Okay. So yeah, so the one that I was taking x upon 1 upon x, that was a wrong example because x can be negative. So then again, it will be difficult because you can get it again from minus infinite. If you put, you'll get 1, right? So that
Yeah,
will
I
not work.
was I was I was telling, like, as
Hmm.
we have x plus 1 by x, sorry, x by 1 plus x in the
Correct.
denominator, 1 x plus 1, and the numerator we having x. So I'm just taking 1 as the numerator and then x plus 1 and then divided x to that.
This one. Huh?
Yeah, and then segmenting like 1 by 1 plus 1 by x.
Oh, that also will not work, no? The same thing, right? 1 upon 1 plus x, right? Correct?
So if we are taking x as
Yeah.
infinity, so
Minus
this
infinite
will
you take.
tend, huh,
If you take minus infinite, again the same thing will happen, right? You will get 1,
hmm.
right? At infinite, x equals to infinite also, the same you will getting 1, right? Correct?
Yes, sir.
Yeah.
Yes.
So this example was not correct. So that is what I was saying. But the question, whatever has been given, right? E to the power x upon 1 plus e to the power x, it has been given so that it is easier to prove that this is a 1 function because e to the power x can't be negative. So if this can't be negative, so it can be, what can be the minimum value? 0, right? So 0 upon 0 plus 1, so 0. And maximum what it can get is infinite. So infinite upon infinite, so it can go to 1 maximum, right? Not 1, but yeah, less than 1, something less than 1. So that's an increasing function. Okay, so that's why this becomes a 1 function. And that's why you can calculate the inverse also. Is this clear or not?
Sir, what my argument is, though it has asked
Basically, now you see
inverse,
this. Yeah.
it has asked the inverse. So we blindly like find the inverse, and if there is a inverse for that, then it is 1 1.
No, that doesn't work like that. You have to first check whether the function is 1 or not, then only you can calculate inverse, right? Even you can calculate the any function, right? Let's, for example, this is the function, right? You will get some equation for sure in the form of some square root or something, right? But that for this equation is not even 1 so you can't calculate. So by equation you can get the inverse, okay? But actually you can't get it.
Okay.
So inverse is those type of function where you can't trace back the value, right? So for any function fx, right? If you are getting some value, right? Let's, for example, 2 or So for any equation, so for this type of equation, right, at 2 you are getting two values, right? So 2 and 4 you are getting. So inverse, if you'll
This is
calculate
not a
here,
function, sir.
which one?
This graph.
Yeah, this is not even a function also.
Yes, sir.
Yeah, this is not even a function because at fx you are getting two values, right? No, I'm just, okay, let's deal about this type of function. Correct? This is a function, but it can be, if you'll calculate the, so by equation, mathematically equation you can get it, but actually you can't have an inverse for this type of function. Okay? See, if you'll try to plot this now, this is, I guess, a sigmoid function, right? So if you just, I just missed out, otherwise this is a sigmoid function, right? Behavior will be similar to sigmoid function, right? It will go something like that, right? Maximum it can go to 1, right? So, yeah, so this function will behave something like that. So 0 to 1 only you can get. Okay, so that's why from minus infinite to infinite, it's an increasing one. It's an increasing function. Many a times we use this. This function is used in ML a lot, right? Okay, leave this. So this is clear, right?
Yes, sir. It's
Okay.
clear.
Okay. How it has been solved. Okay. Yeah. Now the given, you have been given something here. It has been given m equals to 8 factorial 1 to the power 8, and you have been given n equals to 9 factorial 1 upon 9. Now it has been said x factorial. Factorial you already know, right? If you have to calculate 4 factorial, this is nothing but 4 into 3 into 2 into 1. Correct? So now it has been said that which one the 2 is greater and less. Okay. How can you check that? So log of m is what? 1 upon 8 log of 8 factorial. Log of n is 1 upon 9 log of 9 factorial. How will you able to calculate without? So see, one method you can directly calculate the 8 factorial, 9 factorial, and can call. Without that, how will you do that?
Sir, 9 factorial would be 9 into 8 factorial. Uh, then, like, we can do the, uh, we can add that
Yeah,
log
so
of
this will
9.
be log of 9 would be 1 upon 9 log of 9 plus 1 upon 9 log of 8 factorial. Correct? This is what you said?
Yes, sir. Uh,
But then also you are not getting anything, right? Yeah, let's, for example, if you are subtracting log of m minus log of n, what will you get? Log of m minus log of n. So 1 upon 8 log of 8 factorial minus 1 by 9 log of 9 minus 1 by 9 log of 9 factorial. Sorry, log of 8 factorial, right? So 1 upon 8 minus 1 upon 9, how much? 1 upon 8 minus 1 upon 9. 9 minus 1, 1 upon 72. Log of 8 factorial minus 1 by 9 log of 9 factorial, sorry, log of 9. This is what? Log of m minus log of n. Is this positive number or negative number?
Negative, I think so.
Why? Because yeah, see 1 upon 72, right? Then log of 8, correct? Plus 1 upon 72 log of 7, correct? This should be how many times? 8 times, correct? This is 1 upon 9. Okay, let's multiply it. If we'll just multiply 72, so what will happen? 72 again. So you'll be left with what? Log of 8 factorial minus 8 times log of 9 times 72. Okay, now you can get it. So now this will be log of 7, sorry, 8 plus log of 7 minus 8 times log of 9. Yeah, this will be negative, right? Because log of 8 will be less than log of 9, right? And this is 8 times, right? So log of 7 plus log of 6, all will be negative. So overall it will be negative number, right? So m minus n is negative, so n is greater than m.
Is less than.
So m is less than.
So option B.
Eh, Did you understand this? Or should I explain it again?
Sir, please explain it again.
Explain it.
Okay. So what we did is, so you can get the value of m, log of m equals to 1 by 8 log of 8 factorial, correct? Log of n also we got 1 upon 9 log of 9 factorial, correct? What we did. Yeah. So yeah, we have splitted this. So we tried to calculate log of m minus log of n. So we were left with 1 upon 8 log of 8 factorial minus 1 upon 9 log of 9 factorial. So what we did is, yeah, first we splitted this, right? So we left with 1 upon 8 log of 8 factorial minus 1 upon 9 log of 9 minus 1 upon 9 log 8 factorial, correct? And then if you'll subtract this 2, what you will be left with? You will be left with 1 upon 8 minus 1 upon 9 times log of 8 factorial minus 1 upon 9 log 9. Is this clear to everyone? This till now this is clear, right? This was just a calculation. So
Yes,
the
sir.
first step, yeah. So first step, we just take the log of m. If you will take, you will be left with 1 upon 8 log m, 8 factorial. Similarly, log of n will be 1 upon 9 log 9 factorial, right? Now we have to check whether which of the two is correct. So to check, what we did is log of m minus n. So if we'll get it, so m greater than, right? So if we'll just get some positive value, then m is greater than n, right? So what we are trying to do is, what we have done, yeah, 1 upon 8 log 8 factorial minus 1 upon 9 log 9 factorial, right? So first thing first, we have splitted this because this is 9 factorial, so we can split that, right? So 1 upon 9 log of 9 factorial. So 9 is what? 9 factorial is 9 into 8 into 7 something, right? So 1 upon 9 log of 9 plus 1 upon 9 log of 8 factorial we can write. So this is what we have done, log of 1 upon 9 log n and then minus of 1 upon 9 log 8 factorial. And this you can see that log 8 factorial out of log 8 factorial, right? So we can subtract it. 1 upon 8 minus 1 upon 9 times log of 8 factorial minus 1 upon 9 log 9 factorial, correct? So now we can write it as, this is what? 9 minus 8 upon 9 into 8, correct? So that will be 1 upon 72 times log of 8 factorial minus 1 upon 9 log of 9. Now what we have done is, we have just multiplied 72. Why? Just to make the simple calculation, the calculation simple. So 72 got cancelled there. So we'll be left with log of 88 factorial minus 8 times log of 9. Correct? Times 72. Now what you have seen is log of 8 factorial, you can write it as log of 8 plus log of 7, correct? Till log of 1 minus 8 times log of 9. Now you can see that this should be 8 times, right? Log of 8, 7, 6, 4, 3, 2, 1. Okay. You can see that each of the log, so log 8 is less than log 9, correct? So this is 8 times log n. So you can write it as log of 8 minus log of 9 plus log of 7 minus log of 9. All these values will be negative,
Okay,
right?
okay, sir, got it.
So if all these values are negative, so that's why m
Come
minus
again,
negative.
this one, log factorial 8, what you have written?
Yeah, so what I written is, so this is log 8 factorial, right? If log of, so this is something like log of 8 times 7 times 6 times 1,
1 to 8 into,
correct? So
yes,
I can write it as log of 8 plus log of 7
yes, yes,
plus log of 6, right?
yes.
And minus of what? 8 times log of 9. So 1 log 9 I can subtract it from here. 1 log 9 I can subtract it from here, right? All this value will be negative, right? So that's why
Yes,
this m is less than n. Is this clear to everyone?
yes, sir. Sir, we have
So
taken,
log 9, obviously it would be greater than log 8 plus log
Correct,
7.
correct. Yeah, yeah. So that's why this value m minus
That's
n
why.
will be negative. Yeah.
sir, we have taken the log with base 10, right? If we'll take some base which is between 0 and 1, then what will happen in that case?
Yeah.
Uh, so that would be a decreasing function.
No, okay, 1 second. So if you will take log of, okay, we have taken log of any 9 or anything we have taken.
Then that would become like let's take 0.1. In that case, log m to the base 0.1 minus log n to the base 0.1.
Okay, wait. So whatever you are saying, log of any value, log of n minus log of n, this will come out to be negative, right? Okay.
Yes, sir. Uh, so from here we can conclude that n is greater than m because this log function is increasing, right? Uh, so if we'll take some base which is between 0 and 1, then what will happen in that case? Then also we'll get the same inequality, right?
The inequality here, so here log of, okay, so here it will be, everything will be fine. Okay, but okay, 1 second. So then, but yeah, so then what will happen now? You see log of 8, right? And log of 9. If you are putting 0.5 and 0.5, which one will be greater than?
Sir, it's a decreasing function, then
This
this
will be
8,
less, right?
yes, sir, that will be
Then
less.
you'll be getting, this will be less, right?
Yes, sir.
Then you'll get positive, right? Are you getting me? See,
Okay,
you
so
got
sir,
it right.
according to that, the inequality will also change.
Inequality, yeah,
Okay,
correct.
okay, okay, sir, got it.
Hmm. Okay. Okay, I hope this is clear, but yeah, yeah,
So n should
nice.
be greater than m.
Yeah, yeah.
N should be greater than m.
M should be less than n. N
N,
will be greater. Yeah.
n is greater. Like
Yeah, Nepal is greater than Madras. Okay, something like that. Yeah? Okay, let's move to the next problem. Yeah, this is one of the previous term questions, so this is not difficult, simple. Yeah, this type of problem can be asked in the exam, and even this can be asked. Okay, so try to solve this. So what will happen here? X upon y log
Equal
of,
to e to the power a.
yeah, so x upon y will become e to the power a, correct? Similarly, the same thing you can write it here, e to the power a times b minus c. Y upon z, what will happen? E to the power b c minus a, e to the power c, what will happen? A minus b, correct? So ab minus ac, bc minus ba, ac. So everything will get cancelled, right? So we'll be left with what? 1. Something e to the power 0, right?
Yes, sir.
Is this clear to everyone? How we got it? So here you can see e to the power ab minus ac, e to the power bc minus ab, e to the power ac minus bc, right? So you can see that everything will get added, right? E to the power all will get added, ab minus ac plus bc minus ab plus ac minus bc. So ab got cancelled, ac got cancelled, bc got cancelled. So e to the power 0 equals to 1. Fine.
Yes, sir.
Okay. Let's move to the next question. Yeah, you have to calculate the domain for this function. So, okay. So the first thing first, you can split x square minus 11x plus 24 should be greater than 0. The first condition. What are the other condition?
X minus 4 should be greater than 0 and it should not be equal to 1.
It should not be equals to 0 also, right?
Yes, sir. It should be greater than 0, strictly.
Okay. Yeah, it should be greater than 0. So from this three condition, you will get the value of the domain. Should I solve it or you will be able to solve it?
We can solve it, sir. Like we have to take the intersection of all these
Yeah,
things.
all three intersection, because all three should be satisfied. Okay. So
Yes.
1 intersection of 2. Yeah. Anyone have any question? Yeah. Okay. Let's move to the next question. Solve the quadratic equation. This question you have to solve it e to the power 2x minus 7 e to the power x plus 10. Yeah, this type of questions also will be asked in the exam. Okay. Solve it. Which of the following are the valid solution for the equations? This is very simple, right? You can just consider it for x as t. Then you'll be having is t square minus 7t plus 10 equals to 0. What will we get? T equals to 5 and 2, right?
Yes, sir.
So e to the power x equals to 5, e to the power x equals to 2.
ln
So
5
it's
and ln 2.
5 and ln 2. Correct. Yeah. So A and B is correct, right?
Yes, sir.
Simple. Yeah. Again, the similar question, you have to calculate the domain of this function. Yeah, here it has been said that the domain of fx is 0 to 4. Then the domain of this function. What should I do? So this ln of,
This should lie between 0 to 4. This ln of x square minus 1.
correct. So this should lie from 0 to 4. Correct. And from here, whatever the value of x you will be getting, that will be the answer.
Yes, sir. So e to the
So
power
should we
0.
conclude this in two different equations because we can't
Mm.
operate on singularly
Yeah,
on.
you have to operate in two equations. Yeah. One you
Okay.
can write it as ln of x square minus 1 greater than 0. From here you will be getting something. And then ln of x square minus 1 less than 4. Okay, first equation, second equation. Okay, first intersection 2. Okay.
And sir, another thing, we have to conclude x square minus 1 greater than 0 or not?
Now that also should be there.
Okay.
All three. You can't have any value that is like not even satisfying. So that's not in the domain of this ln x. That we can't have. Those value also you have to exclude. Those are not in the domain of x, this function ln of x square minus 1. But that is already came, right? Ln of x square minus 1 is from 0 to 4, right? That is already greater than 0. No, sorry. X square minus 1 should be greater than 0. Yeah, that is also a condition. Yeah. Okay, so let me check if there is any other question apart from domain. So again, this is also same question. So this is also domain. I'll go through it, but let's solve. Okay, let's solve this one. This is not the domain one. How will you solve this question? And then we can go there. Okay. First, I'll just reiterate. I guess there are a lot of questions there. So the domain wala will solve in the end. First, we'll try to solve the other different type of other questions. Okay. How can you solve this? So this is something like x plus y plus z equals to 0. You have been asked to calculate x cube plus y cube plus z cube.
Can we write it like log b divided by log a by change of
Yeah, you
this?
can write. Yeah, you can write it. Log b by log a, but how plus log c by log b plus log a by log c equals to 0. But what we will get here? I don't think so we'll get anything here. Are we getting anything here? So if we just get log of b times log of c, log of a, log of b, log of c, log of b and ac plus log of I will not get anything from there, I guess. I guess we have to use that. There is some formula, right? Some
Yes, sir.
cube this will
A
get
plus
something.
b plus c the whole cube.
What will you get here? It has something
That
we
is
get.
x cube plus y cube plus z cube plus 3 into a plus b, 3 into x plus y,
3 into
and x
7.
plus y, uh, then y plus z into, sir, into, that should be
Okay.
multiplied.
Sorry. Plus 3 into ax plus y,
Into
like
y
this
plus
thing.
z, yes, sir,
Okay,
into z plus x,
that's it.
yes, sir. This is the formula of x plus y plus z to the power cube. We can equate it to 0, right?
Yeah, we can equate it to 0. That is fine. I guess there's something else we're missing. X cube plus Q.
And sir, also in the options, it is asking about like the behavior of this of the
Mhm.
answer.
In this type of question, you'll get either 0 or 1. So I guess you'll get it as odd number because 0 you can't say anything. So you can get it odd prime. 1. Okay, so is there any other formula that maybe say K plus Z? So if you are given a plus b plus c ka LQ equals to 0, aq plus bq. You have to see what we are supposed to do, right? We have to write it this equation in term of something like x plus y plus z, so that this will become 0. That's why it has been given. Okay, and then should be multiplication of something. Are you getting? So this, it should be something like, so you have to expand this and then write it in this form, where x plus y plus z should be common, and then here it should be something. So this will get multiplied, so 0 will get multiplied with this. Let's check the solution what has been given here. See here, okay, this equation, there is some equation. I hope this is the equation. Yeah, in when in class 9, 10 we used to study, right? If x plus y plus z equals to 0, then x cube plus y cube plus z cube will be something like 3ab x y z, right? This we used to read, right? I guess that equation only you have to use it. Yeah, because this will become 0, so that's why this was given, x plus y plus z was given as 0. And then if this becomes 0, then you're left with x cube plus y cube plus z cube equals to 3xyz. Okay, I don't think so this type of questions will be asked in the exam. Okay, not important at all. Okay, this formulas and all we have
So I
read it.
think it's based on some identity also.
What?
It's somewhat previous identity from the ninth or 10th.
Yeah, correct. Yeah,
Don't
this
think
type of
it's
questions will not be asked. Okay, but even though if it was given, you can just get it as.
Sir, like how this xyz is the multiplication of this log functions. How this is?
This one, huh?
Yes, sir. How this
Ah,
becomes one?
okay. Well, this becomes 1 because log of b upon log of a, right? Times log of c upon log of b
Okay.
times log of a upon log of c. So
Yes,
this
sir.
will get cancelled.
Okay, sir.
Okay, but yeah, so this is something like x plus y plus z equals to 0, then you can directly get it x cube plus y cube plus z cube equals to. So this goes for something that people who are already knowing this will be able to solve it, but I don't think so they will be asked in the paper. Let's try to solve this one. This is simple, not difficult. There is nothing else to be used here. So how will you solve log of 2 x plus y x plus 4 minus log of 2 x by 2 plus 2 equals to 1. So this can come here, right?
yes.
So this will become 2 times log of x plus 4 base 2 minus log of 2, sorry, this will become x plus 4 by 2 equals to 1. Now this will become square.
And that will be divided.
Okay, sorry. What, it's better to do this. 2 log of x plus 4 base 2, and this will become log of x plus 4, right? And then minus log of
1. That will be log of 2 to the base 2.
uh, yeah, log of base 2 to the base, sorry. This will become 1, right? Minus of 1.
Yes, sir.
So from here 1 will get cancelled, so we'll be left with log of x plus 4 base 2 equals to 2, correct? So x plus 4 becomes 4. Is it like that, or okay, then the x we are
Yes,
getting
x should be 0. Or like
0 is not in the option, right? Okay. Any error that we are doing? Any mistake? So this we have done it correctly.
In the
Yeah.
second step, in the initial, you have written, 2 to the power 1 by 2 becomes how it's 2.
This will
Why not
become
1
1
by 2?
upon this, no? 1 upon 1 by 2. So this 2.
Not getting here.
Sir,
Uh,
else we can just do that base change formula, right? We can make everything to the base 2.
that is what we have done, right?
Okay.
Log of say 2 square is here, right? So what you write? Log of 1 by 2. Okay, so if we have something like log of x and 2 square, what do you write? Log of x
X.
base to 1 upon 2, correct?
Okay.
Yes, sir.
Yeah. So here it is 1 by 2. So 1 upon 1 by 2 is 2, right?
Yes, sir.
Okay.
You got it, right?
Yes.
So here this is fine. This is fine. No problem here. Here also no problem. 2 times log of x plus 4 minus log of x plus 4. Okay, this will be plus, right? Minus of minus 1. So 1 plus 1, right?
Yes, sir. That will get cancelled then.
So this will get cancelled. So you will be left with what? Log of 1 will get cancelled here. So log of x plus 4 equals to 0.
Yes, sir.
Yeah.
It should be
So
minus 3x.
x plus 4 equals to
1.
2. Yeah, 1. Right? X equals to minus 3. Is this clear to everyone? Have you understood?
Yes, sir. It's clear.
Okay. Whatever this question, evaluate the following sum. Here the base change you'll have to use it. If you'll change the base, what will happen?
Log 2 by log n, log 3 by log n, and like that only.
Okay. So what can you write if we have
Yes,
1
sir.
upon
Sir.
log of n base k? What can I write for this? 1 upon log of n log of k, correct?
Log of k. Right.
So can we write it like this? K n, right? Write it. So now for this, what should I write? For the first one, 1 upon log n base
That
2.
should be
Can do
1 by log n divided by log 2
n
means log
k.
2 by
Log
divided by log
2
n.
n k. Log 2 n.
Log 2
Log
divided
base
by
n, correct?
Yes.
sir.
Log n2
Correct?
n3.
Yes, sir.
Now, yeah. So now, what should I do? So now, can we do it like 2 into 3 into 4 till 43? This is an addition, right? Can we do it like this? in the
Yes, sir.
multiplication, correct? So now if
Factorial
this is
40.
something, yeah, this is something for total 43 only. And times 43, what is the n? N is also factorial 43 only. So we'll be left with 1.
Sir, we have taken n here, right?
N is
Ha ha.
43
Ha ha
factorial.
ha.
It's been
Yes, sir.
given in the question, right?
Yes,
Yeah.
sir. Then it would be 1.
Okay.
Also, we are, yeah,
Yeah, go ahead.
no, got it. Since we are doing it n 43 times, so it naturally would
Mm-hmm.
be n 43.
Okay. Whatever this question, where will be something which of the following holds true. So you have been given here x equals to some value. Okay, you have to take the base 10 only. Then which of the following holds true? What is log of x? Log of 3 times log of 2, right? Log of y is log of 2 times log of 3. Both are same, right?
Yes, sir.
Yeah, both are same. X equals to y. If you will take log of x, log 3 will come here and then log of 2, right? And then again here, log, if we'll take log of y, so log y will come here, log 2 will come here, and log of 3 will multiply. So this was simple, very simple. Okay, let's move to the next problem. Find the number of ordered pair xy of all positive real numbers satisfying this system of equation. This is a bit difficult problem. It will take some time to solve it. Okay, how can you solve? How will you? So there are two equations that has been given to you, right? And you have to solve xy, right? Okay, let's try to solve this. Let's just say log of x by y will be equals to
2.
2. So x by y is 4, correct?
Yes, sir.
So x equals to 4y. Yeah, let's try to put here in the first equation. Plus y log 4y base 2 equals to 16. Okay, what all we can do?
4y can be written as 2 into 2y, then
We can write it as 4 times log of y base 2 times y log of y base 2, correct?
Yes, sir.
Is y times log of 4 base 2 plus log of y base 2, correct, equals to 16. Okay, so now here this can be exchanged. So we'll be left with what? Y is the power log of 4 base 2, same y log of y base 2 plus y. This will be what? 2 plus log of y base 2. Again, this will be y square times y log of y base 2 plus y 2 plus log of y base 2. Both are same only, right? Yeah, both are same. See, both are same. What can I do? So this is nothing but
2 into
correct. Yeah,
that
2
should be
into
equal to 8.
2 plus log of y base 2 equals to 16. So that is 8. Correct?
Yes, sir.
Now what can we do? Take log on both sides. So 2 plus log of y base 2
Then
times log of y base 2 equals to what? Log of 8. Take this as t. So 2 plus t times t equals to log of 8.
the log actually that should be log 8 to the base 2 means
yeah,
that
3.
will become 3.
Correct. This will become 3. So now it's simple. T square plus 2t minus 3 equals to 0. So t is what? Minus 3 and t equals to minus 3 and t equals to 1, right?
Yes, sir.
Correct. Okay. So now log of y base 2 equals to minus 3. And then log of y base 2 equals to 1. What will you get? Y equals to 2
2
here.
to the power minus 3 there.
Okay. Okay. So for two values, right, you will get 2x. So two ordered pair, right? This is what you've been asked to calculate. 2 is the answer.
So ideally, will we getting such tougher question?
No, you'll not be getting this type of questions in the exam. Which type of questions you can get it is like I told you, right? This question, first question you can get it. Even second you can get it. So even third also you can get it. But yeah, a lot of computational questions you will not be getting. Okay? And even this time too, after this quiz one, like the result we have just the quiz two is not difficult, very simple. Okay. If you are able to solve this type of problem, I don't think so there will be any issue in the exam. They're much
Why,
simpler.
sir? Was quiz one result not good on average? That's why they are giving easy.
It was not good. So the
Any
quiz,
update on my the request I put on the last
but I
class?
didn't got any mail from you.
I just dropped you mail.
What's your mail ID?
Just a second.
I didn't got any mail. So
My mail ID is 25f 300
25 years.
5182.
No, I didn't got anything from your side.
But your mail ID is vishal at the rate study.iitm.ac.in. Is that correct?
Yeah.
Yeah, I have dropped a mail and it has been delivered on Sunday, 22nd March, 10:23 p.m.
I didn't got any. Ayus, sir? No, sorry, not Ayus.
Okay. Is there any alternative channel to share my, request or?
Because I don't have anything like no any other channel. Okay, you can write it to support.
Let me forward it to you.
Okay, study.
I have resent it, re-forwarded it to you. Kindly check.
No, I didn't. Okay, can you just drop the mail ID that you're using? Copy pasting it because I didn't got it now also. So there is something that vishal@study.itm.ac.in. Okay.
This is the mail ID which I have used.
Okay, so we have left some of the questions, right? Okay. How will you calculate the domain for this function? You try it. Yeah, now I got it. Sorry, no, no, no. That also is not yours, I guess. Yeah, this is yours only. Yeah. Tanmay, right?
Yes, correct.
Okay. Yeah, you have sent me 2 days back. Oh, I could.
It might have gone to your spam folder.
No, it was not in spam, but I somehow I missed it. Yeah.
Okay.
Okay, I'll just forward this to the concerned team. Maybe they'll talk to this wherever your exam was. So they will talk to, if there was some issue, then they'll let us know. Okay. Thank you. I'm sorry for that, but yeah, somehow. Okay. How will we solve this? This should be one of the last question because almost every question is similar to that. So
The quadratic argument would be positive,
yeah, this
greater than 0.
You can have two inequalities.
Also, the 1 minus that also would be positive.
okay. Yeah. So
Two
two things.
inequalities we will solve first.
Yeah. Two inequality. One is this one greater than 0, and again this one greater than 0.
So I just had one more doubt apart from this. So I was seeing that, in the recent assignments for stats, there are mostly NAT type questions, but like majority questions, more than 50% are NAT. So will these quiz two examinations have more NAT questions?
No, see, there is some while sending out the questions, right? There are some generally NAT will be around 40 to 45%. In the quiz one also, I guess you would have seen, right? So there is a no,
So
unsaid
I
rule.
think quiz
Yes.
two, quiz one, maths had more NAT than stats in my view. Like stats had relatively lesser NATs.
Okay, is it? But yeah, but
Yeah.
that is what there is some unsaid. It's like there is no yeah, rule or something. But yeah, that is what I see is like around 40 to 45% of the questions comes out to be NAT. Okay.
Okay.
Or sometimes it will be less also, but yeah, it will be like 30 to 40% of the paper will be NAT. So around out of 50 marks, you will have some 30% of that 15 to 20 marks of the paper in NAT. Okay.
So
Thank
sorry
you.
to ask, but what is NAT?
A numerical answer where you just put the values. Apart from MCQ and MSQ that you get.
Okay.
Yeah. So same will happen in the quiz too also. You'll get some in maths. I can tell you, you'll be having some out of 50, some 20 marks of the questions NAT. Huh? Not
Yeah,
exactly
thank
20,
you.
but yeah, around 20.
Okay.
So this should be option A.
Yeah, option A is correct.
Okay, sir.
You can
So,
just mark it a log of.
So this
X
x
is
square minus 5x plus 16 is always greater than 0.
oh, is it? Okay, so
Because
Also, sir, I'm
d
sorry
is
to
less than 0 here.
oh, discriminant is negative, right? Okay.
Yes, sir. So, and our vertex is also positive. So
Mm-hmm.
we would get
Okay, then there is you don't have to check it for the inner condition. Just the outer condition will give, right? So log of x square minus 5x plus 16
should be less than 1.
less than 1. So x square minus 5x plus 16 should be less than 10. So x square minus 5x plus
Plus
6 less
6.
than 0. So this is x minus 2, x minus 3 less than 0. So this correct?
Yes, sir.
Or the opposite? Less than, right? Yeah. So 2 and 3. Here it will be negative, positive, positive. So 2 to 3 will be the answer. The first option is correct. Anyone has any doubt in this?
Sir, I just wanted to, I'm sorry to interrupt again on this, but I
Yeah.
wanted to confirm one more thing. Yesterday, the stats instructor said that the syllabus for for quiz 2 will be week 4 to 8. So is that, sorry, week 5 to 8. So is that similar for maths as well?
Yeah, maths also week 5 to 8. But yeah, see, the problem in maths is you can have, let's for example, something related to some concept where you have to use the quadratic equation
No,
concept, right?
yeah. So the point is, I understand that, but it just gives a reference
Yeah,
because
the
we do not
syllabus
have to go
is,
to the theory of all of it
yeah,
again,
yeah.
right?
The
I mean,
syllabus is
obviously,
week 5 to 8,
quadratic is
correct?
generally applied everywhere. Sets like we are using bijective, injective function, we is
Mm-hmm.
completely different. But it's just that you don't have to go to the theory and all of it depends.
Yeah, the syllabus is from week
Like
5 to 8, but yeah.
for instance, there will be no question for monotonicity or turning points, right? Because
Yeah,
they are
no, there won't
largely
be any core concept of week 1 to 4.
exactly, yeah.
Week 5 to 8. But yeah, if there are some questions where you have to use the concept of week 1 to 4, then
Yes, like I
yeah.
understand that sets concept is used generally and or
Mhm.
quadratic is obviously used like that, but it's just that. Thank
Yeah,
you.
the syllabus is from week 5 to 8 only for maths. That I said in last session also. But yeah, this is what the syllabus
Oh, I
is.
might have missed that when you
Oh, okay,
said.
that's yeah, totally fine. Yeah, but yeah, might be some concept that will have to use it, I guess. So that's why when many a times I don't say that, because otherwise, if what happens in the previous terms and all, what happens if there are concept where quadratic functions concept I use, then people say that those are from week 3 and all. So that's why we don't like say that. Just say that week 1 to 8, so that everything people will revise. But yeah, I'm just saying week 5 to 8 will be the core. But yeah, there won't be any question particularly from like a Venn diagram question. Those things will not be asked, okay, in week in quiz 2, because those things are already we have asked and checked it, okay. So now in the final quiz will be asked from the whole concept, where very less of the topics will be from week 1 to 8. High percentage, maybe 60 to 70% of the questions will be from the last 3 weeks, 9, 10, 11, because in maths 2 you don't have, maths 1 you don't have a 12th week. So and the remaining 30% will be from week 1 to 8 in the quiz in term, okay, final quiz.
So,
Same is the case for the quiz 2 also.
so comprehensive is also MCQ, MSQ, and NETs,
Which one?
and the comprehensive exams.
Comprehension questions, huh?
Comprehensive exams, end term exams, final exams of the term.
In the end term exam, yeah, yeah, then you will have. So what you're asking, I am not getting. Sorry, what
I'm
you're
saying
asking?
the comprehensive end term exam is also MSQ, MCQ, and NET.
Yeah, yeah, the final quiz is also same.
Everything
There,
is fine, but
there won't be any pen and paper exam like for this maths one. There are courses where pen and paper are there, but not for maths one. Okay.
Okay.
there are sometimes that I get confused with the inequality part. I couldn't, figure out the inequality correctly.
Okay, for logarithm, huh?
For logarithm. Like I proceeded correctly, but the inequality in the third step I took it wrong.
You take the same inequality, no? Whatever has been
Like the
written in the
log
question.
10, 1 minus log this expression is greater than 0. That I took it correctly. Also,
Correct.
took the expression log 10, that expression should be
Correct.
less
Correct.
than 1 because
Correct.
as 1 is the greater value.
Yeah. Yeah.
Okay.
Hmm.
But in the next step, I took the expression wrong.
Why, like this same equation you take now, whatever is there in the left side, you take it in the left side. Whatever is there in the right side, take it. But if the base is less than one, right, then you invert, like do the opposite. Otherwise, whatever is written, you just write it in left hand side only, and right hand side, you just write it in the right hand side only. No, and do not change this inequality. No? If the base are greater than, so like here it has been written, right, log of whatever x square minus 5x plus 16 less than 1, right? You write this here only, x square minus 5x
The thing
plus
is that I'm
16.
struggling with the inequality thing, like the
And then you
concept
can
part.
write it as 10, 10. That's it.
Is there any document or any PDFs that I can refer to for the inequality part?
There is no document as such. But I'll check. There's no document, but yeah, I can just send you some
Any
screenshots
notes
on
or
this.
anything like that which I can refer to?
Wait, I'll check if I have it or not. Yeah, you can take the screenshot of this. Maybe that will help you.
Share it on the chat window so that
Okay, I'll upload this file in the wherever I'm uploading everything, right? Okay,
from where
that
can I download it? From the
I
course
have
dashboard.
shared, yeah, I've shared the drive file I've shared, right? Where I'm uploading all the files that I'm used during the session. So there I'll upload it. Okay.
Kindly reshare that link so that I can have access.
Okay. Yeah. Okay. Is this clear, right? So I hope most of the question we have already discussed. Yeah, there are some questions regarding domain and all, so that we can do. This is the last question. Is a proof, like I guess. And this question, see, many of the question you might feel like these are the difficult problem. These are just for the practices. The question that will be asked in the paper will be much easier. That I can tell you. Okay. Maybe the mock paper that will come, right, that might reflect the difficulty level. So this time what I'm thought of, mock will be almost similar difficulty level of your paper. Last time maybe the mock was a bit difficult than the paper. This time what I'll do is mock, I'll just put the same number of questions, similar, like almost I'll try to put it the similar MCQ, MSQ and NAT. Okay, so that you will get an idea about that. How will you solve this? Can you write this as A plus B whole square minus 2AB equals to 23ab, correct? So a plus b का whole square equals to 25ab. A plus b equals to 5ab. Okay, now take log, right? After taking log, you will be getting, right?
Yes, sir. We can multiply that 2 in the other side.
Which one?
Uh, Sir, this will be 2 into log
Okay,
of
here.
a plus b.
A plus b by 5 you're saying equals to root ab. If you will take log on both side, it will be log of a plus b by 5 equals to 1 by 2 log of a plus 1 by 2 log of b. Correct? This is what has been asked to prove.
Yes, sir. That ab becomes, we can add that.
Yeah,
Yes, sir.
correct.
That is what. Yes.
Yeah, this is what has been given. Okay. Yeah, any doubt anybody has from this all whatever we have discussed today?
So last one can be asked in the quiz.
No, proof and all will not be asked. Okay, these are all for the practices. Okay, so that's why I've taken some a bit difficult problem to practice. But otherwise, the paper will be proof and all will not be asked in the paper.
But sir, these questions are very good questions. I mean,
Yeah, so these all is just for the practices. Okay, so you'll be getting some questions like let's say example I'm telling you. These all questions will not be asked in the paper because it will take a lot of computation, right? So see this question was easy, right? This can be asked. Okay. Similarly, this also can be asked. Not the difficult problem. This can be asked. Okay, and this has been asked. I guess this is one of the previous term questions only. This has already been asked in one of the paper. Okay, this will not be asked. Okay. This is also, I guess, is asked somewhere. Okay, in one of the qualifier paper, not qualifier, so we can't ask. Okay, some of the paper it has been asked in term or maybe quiz too. Okay, this type of questions has been repeatedly asked. Okay, where you have been given some equation, and then you have to just think of how to solve this. Okay, maybe they'll be asking you what's the number of solution or the solutions. Okay, so this is what will be asked in the paper. Any doubt from today's session that you have
The
felt?
ML subject and all, will the our equation turn out to be like this, like real life example?
See, logarithm and all mostly is used in ML a lot. Okay, so when you'll be learning about the likelihood, right, maximum likelihood functions and all, there we use the logarithm function. In real life, if you're asking whether we use log a lot or not, we use it many a times. Okay, uh, in ML we use it a lot. In a lot means like there are some part of ML where in let's say example in clustering model, right? Whenever in clustering or maybe in estimation also we use mostly we use it to for the estimation. Okay, if you have to estimate some sort of a parameter. Okay, so there we have a likelihood function, and the log generally helps us because log has a very nice character, right? So if you have something in the form of multiplication, log will do the addition, right? And then log is very monotonic. So if you have some sort of a convex or a concave function, it will not change the character of the function. Okay, that is inside the logarithm. So that's why log, because of the monotonicity, right, the log has, that's why you use it. If you have an increasing function, the log will also increase. If you have a decreasing function inside the log will decrease. So because of that monotonicity, right, we use the log a lot. Okay. Yeah.
okay, sir.
Hmm. Okay. So okay, we'll meet again in the next session. We'll start with week 7. So I guess limit and continuity from the next session.
Okay,
Any
sir. Thank you, sir.
no doubt, right? Okay. If anybody has any doubt, you can just let me know. Otherwise, we'll just close it off.
No doubt. Only drop the link of the your OneDrive so that we can We can
Okay.
access
The
that. I
drive
don't
link
have
you
that.
don't have, huh? Like nobody has a drive link.
Oh, if you can reshare, I'm not sure. There are many links that were shared, so I'm not sure which link I've saved and which not.
Okay. Can somebody share it, because I am using tab, so I don't have the link right now. So if anybody has, can you just share the Google Drive link that I have shared, where I upload all the. Okay, wait. If somebody can upload it, it's fine. Otherwise, I'll have to connect it with the laptop and then upload. I guess nobody has.
Sir, what do we need to upload?
Well, you have the drive link that I generally upload my notes there, that I have
Okay,
shared,
okay,
right?
sir.
You have it, you can just share it in the chat box.
Okay, sir. I'm finding that.
Okay.
Sir, I'm not sure if this one is correct or not.
Okay, this is the seat, right? There is a drive. Okay. So I've attached in the calendar. You can just check from the calendar. So in the calendar, if you'll go in the calendar, there is a link has been attached in today's session. Okay. From there, you can access. Can you see that? So in today's session, right? Today's, if you'll just go to the calendar,
I'm checking.
Yeah, I'm on the calendar, but I don't see.
can you just refresh it? You'll get.
Ah, yes, drive link.
Yeah. So there I'll upload it. Okay.
Okay.
So all the sessions are uploaded there itself. All the you can find it there. Today's session also I'll upload it, and then this notes also, whatever you were asking, I'll upload it there. Thanks. Thank you everyone. Bye bye. We'll meet in the next session.